Welcome friends, myself Rutu Patel, lecturer in chemistry at Parul Institute of Engineering and Technology welcomes you all to the active learning video session on the chemistry. Today we will be discussing the chapter number 2, that is ionization and electrochemistry, that is covered in GTU Diploma syllabus. Now let us try to move ahead. Today's session will cover the topics of the first is theory of ionization and factors affecting it, Arrhenius theory of ionization, pH concept, sums related to that, applications of pH. Then we have buffer solution, its types, application of buffer solution, types of electrolytes, metallic conductors, electrolytic conductors, Ohm's law, specific conductance, specific resistance, equivalent conductance, molar conductance, effect of dilution on electrical conductance, electroplating, electrotyping, electrorefining, p-type and n-type semiconductors. Let us try to begin up with the basic concepts of the electrochemistry first. We have to understand this concept before understanding the ionization and the pH concept. That the first thing that is there, if you see here, there is, I'll draw the things. You have a metal strip, okay? This is a metal strip that is basically dipped into a solution of your electrolyte. So what happens here? This is known as your electrode. This is known as your electrolyte. And suppose if this is a copper strip, then copper strip is acting as your electrode. If this is a solution of the copper sulfate, then it will act as your electrolyte. So one has to understand this. Now whenever I am connecting two strips together, okay, with the help of ammeter and passing the current, then what happens? This your electrolyte will basically break into ions, and this process is known as your electrolysis. Okay, so this one has to understand the concept. So suppose if I am connecting the two strips here, and if I draw like this, then what will happen? Here this is positive electrode, this is negative electrode. So what happens here? Whenever I am passing current through this solution, then what will happen? This electrolyte will break into ions, and the process is known as electrolysis. Based on all this concept, Arrhenius has discussed many concepts that we will be taking up later. Let us try to understand the basic definition first. So if you see here, electrode is a metal strip or rod that is dipped into solution. Now if you see electrolyte, it is basically the salt solution which forms ions in the water. Whenever we pass the current into electrolyte, then this electrolyte breaks into ions, and this process is known as electrolysis. Then we come to the electrochemistry. Okay, so why this electrochemistry? Because the chemistry is basically dealing with the transfer of the electrons. That is why it is known as your electrochemistry. Now if you see the definition of the electrochemical cell, it means the cell which converts your chemical energy to electrical energy is called electrochemical cell. The sixth definition, that is very important, that is ionization. Now see, what is ionization? The process of splitting of electrolyte into ions when you are dissolving into water or any other solvent. Say suppose I have NaCl, and if I dissolve it into water, then what will happen? It will form Na plus ions and Cl minus ions, and this process is known as your ionization. You can see the another basic concept, that is cation. If you see cation, then cation is what? Positively charged ions. Means you have, suppose, look here, suppose you have NaCl. It means your Na plus is your cation, okay, because it is positively charged ion, and Cl minus is your anion. So this one has to understand, and always remember cation carries the positive charge, so it will be always attracted towards the cathode, and anions carry negative charge, that will, so it will be always attracted towards anode. This one has to remember. Now let us try to see the definition of the anode and cathode. Cathode is basically our negative electrode, okay? That is why it is attracting positively charged ions, and anode is basically our positive electrode. Now look at the oxidation. Basically oxidation is removal of electrons, and reduction is addition of the electrons, and redox reaction is the reaction in which oxidation and reductions take place at the same time. Let us try to understand the redox reaction. Suppose we have like this, we are having the strip of the zinc, okay? This is zinc strip, okay? That is our electrode, and if I am dipping it into my copper sulfate solution, that is my electrolyte, okay? Now what happens in the reaction? If you see here, zinc strip is dipped into copper sulfate solution, okay? So basically it is going to form ZnSO4 plus copper, okay? And that is why after some time this strip will get corroded, and you will be able to get the strip structure something like this, because there is corrosion process occurring into the beaker due to the transfer of the cations. This one has to remember. The below reaction occurs that shows that zinc is replacing the copper ions in the solution. So it means zinc is undergoing oxidation and copper is undergoing reduction. Now let us try to write the chemical reaction. How can we write? You have zinc, okay? Here is a zinc, so it is undergoing oxidation. So zinc is going to form Zn plus 2 ions, and 2 electrons are removed in the process. And for copper, you have copper is accepting, okay? So what happens here? Copper plus 2 electrons, okay? So you have copper in the plus 2 state, it is accepting 2 electrons, and that is why it will undergo to the zero oxidation state, that is going to form your copper. So this process shows that this has undergone oxidation, this has undergone reduction. 0 to plus 2 state transition and plus 2 state to 0 transition. Hence oxidation and reduction both are taking place in the process. So this is a well-known example for our redox reaction. So one has to remember the reaction with the drawing. Let us try to move ahead. Two concepts that need to be understood, that is a strong electrolyte and weak electrolyte. Strong electrolyte are basically the substances which undergoes complete ionization. For example, you have HCl, that is hydrochloric acid, strong acid, and NaOH, that is sodium hydroxide, that is strong base. These undergo the complete ionization. It means it is going to form H plus ions and Cl minus ions, and Na plus ion and OH minus ions. Now second is your weak electrolyte. Weak electrolyte are the basically substances that undergoes incomplete ionization. That is, example is acetic acid, CH3COH, and ammonium hydroxide, that is NH4OH. Okay. Now let us try to discuss the Arrhenius theory of ionization. What does this theory states? Okay, keeping into mind the diagram, we can say that Arrhenius theory first point says that whenever you are dissolving electrolyte into your water, it is undergoing dissociation into positive and negative ions. Okay. The second point, it says at a moderate concentration, equilibrium is going to exist between ions and undissociated molecules. Third point of the Arrhenius theory states that total positive charge on cation is equal to total negative charge on anion in the solution. It means there is balancing of the charges into the solution. Fourth point states whenever you are applying electricity to this electrolyte, then what happens? Your cations will move towards cathode and your anions will move towards anode. That is the fourth point covered in the Arrhenius theory. Fifth point, properties of the electrolyte. Okay, whatever electrolyte you are choosing are the properties of ions produced by it. It means what? The ions produced by it will determine the property of the electrolyte in the solution. Sixth point, electrolyte at a given dilution may not be completely ionized, and fraction of the total molecule ionized is called degree of ionization. This degree of ionization is very important concept to be understood, because this degree of ionization will help us to find out how much molecules has actually undergone ionization when we are dissolving it into any solvent. Let us try to study the formula. If you see here, degree of ionization is equal to number of molecules ionized divided by total number of molecules dissolved. To understand this formula, I have chosen one example that you can very well see here. Suppose if 0.04 moles of compound is dissolved in water, okay, we are taking 0.04 mole of a compound and we are dissolving it in water. Now what happens? When we dissolve in the water, 0.02 moles are only ionized. Then if we want to find the degree of ionization, how we will find? Just refer the formula. Number of molecule ionized divided by total number of molecules dissolved. Look here. How many molecules are ionized? That is 0.02 divided by how many molecules are dissolved? Moles are dissolved, 0.04. So degree of ionization is 0.02 divided by 0.04, that is 0.5. Let us try to move ahead. Factors that are basically affecting your degree of ionization. We have seen what is degree of ionization. Now we are studying how the factors are basically affecting it. We have seen, look here, the first point, that is the nature of the ionic compound, that is very important factor that affects degree of ionization. If you see here, if there is a strong electrolyte, what will happen? This strong electrolyte will undergo complete ionization, okay? And if there is a weak electrolyte, then it will undergo incomplete ionization. So these are the first factor. Second factor says the nature of the solvent. Which solvent basically you are choosing, that also determines the degree of ionization. So if you are choosing polar solvents like water, okay, then the ionization will be more, and if you are choosing non-polar solvents, then ionization will be less. Third point, dilution of the solution. Suppose you have a solution and you are diluting it, adding more and more of your solvent, then what happens? Whenever you are diluting your solution, then what happens? There will be more ionization, and if you are increasing temperature, then also the ionization will be more. Now coming to the very important concept, after understanding the ionization concept, let us try to understand the pH. Now this pH is very important concept that is basically used in today's world. So it is defined as negative logarithm of concentration of H3O plus ions expressed in moles per liter to the base 10. If you see here the mathematical form of the pH, then you can see whatever is said exactly into definition is incorporated here. Minus log of H3O plus means what? Negative logarithm of concentration of H3O plus ions that are expressed in moles per liter to the base 10. The square indicates the concentration of the H3O plus ions. Now why this pH is very important? See, in the biomedical field, if you see, urine and blood pH determination is very important. Then in chemical laboratory, we can find out whether the given solution is acid, base or neutral solution by knowing the pH. In paper and textile industries also pH plays a very important role in controlling the products. In city water supply, we always check out the water pH so that while supplying the water to the city, because domestic water that we are using has to be taken care before sending it to the cities. Now in agriculture field, knowing the soil nature is also very important before planting the crops. So there, knowing the soil pH is very important before planting our crops. Now what are this buffer solution? See, the solution which resists change in pH is called buffer solution. It means what? That this buffer solution are very much less, you can say it is almost resisting the change in pH. Like you have any buffer solution, you are adding little acid, you are adding little base, then it will not show a very quick change in the pH. It will first try to resist, and if you increase very high concentration is added, then only it is going to show the change. Basically there are two types of buffer, that is your acidic buffer and basic buffer. In that, you can see here very well that you have the characteristics of the buffer solution. Why this buffer solution is having very peculiar nature? It is having definite pH. Okay, its pH is not getting altered even after a long time. That means it is resisting the change in pH. Then the important thing, that is whenever you are diluting the solution, then also the pH value is basically not changing. Now the types of buffer, acidic buffer and basic buffer taken into detail. Look here, acidic buffer, how it is formed. It is formed by mixing a solution of weak acid with an equally concentrated solution of salt formed by that acid with strong base. What does this mean? Suppose you are having weak acid, that is your acetic acid. Okay, now what it says, mixing the weak acid, okay, with the salt formed by that weak acid with the strong base. It means you are mixing it with CH3COONA salt. Okay, and this salt, how it is formed? It is formed by mixing your acetic acid and your strong base, that is sodium hydroxide. So these two mixture is basically your, you can say that acidic buffer. Okay, it is the example of your acidic buffer. That one has to keep in mind according to the definition. Coming to the basic buffer, that is, it is formed by mixing solution of weak base with an equally constant